Alright guys, today's video lesson should be a little bit shorter than the other ones have been. Today we're looking at recursive sequences, so it's a lot of what we've been looking at before where it's just a sequence of numbers. Today though, all of those sequences, so all of the terms are going to have to do with terms that either come before it or after it. And that's what recursive sequence means. It means the term itself has something to do with either just one term before it or sometimes even a couple terms that come before that one. These are usually the hardest because there isn't a general term that we can come up with, so there's not an equation that we can come up with where we can just plug, say we're looking for the 8th term in the sequence, we can just plug 8 into n like we have with the arithmetic and geometric, and we end up with whatever the 8th term is. For these recursive sequences, you need to know if a term has something to do with the two terms before it. We need to know what those two terms are in order to figure out the one we're looking for. So this one, there isn't a general formula. We need to kind of find every single term in the sequence to figure out what it is we're looking for. So the first one that we're going to look at is what we call the Fibonacci sequence. It's one of the most famous examples of a recursive sequence, and it was actually discovered when this mathematician, whose nickname is Fibonacci, thought about mating patterns of rabbits for some reason and came up with these numbers basically to represent this mating pattern. So the Fibonacci sequence follows the pattern that you see there, so 1, 1, 2, 3, 5, 8, 13, 21, 34. Essentially what they're doing here is to get kind of the next number in the sequence, you're adding the two numbers before it. So this is what I was talking about. Some recursive sequences, in order to find the next number, you have to know the term or the two terms or sometimes even the three terms before it. In this case, to get the next one, we're adding the two that come before. So if you look at it, 1 plus 1 gives us 2. 1 plus 2 gives us 3. 2 plus 3 gives us 5, 3 plus 5 gives us 8, and so on and so on. So we'll write that down, again like I said, so T3 equals 2, which is 1 plus 1, or T2 plus T1. T4, if we look at it, is 3, or 2 plus 1, which is T3 plus T2, and we could go on and on and on. Essentially what this is going to end up is t to the n, whatever term we're looking for, is going to be equal to t to the n minus 1 plus t to the n minus 2. So again, in order to figure out, say we wanted to find out the 20th term, we would need to know what the 19th term is and the 18th term, so we can add those together to give us the 20th one. To figure out the 19th, we need 18th and 17th, and so on. So you can see with these recursive sequences, they can be a little bit tedious because we need to find basically every term in the sequence up to the one that we're looking for. Determining the next terms in a recursive sequence. So recursive sequences can be used to determine the next few terms, but like I said, you need to kind of find every term in that sequence to find the one you're looking for. So the example, we want to determine the first 5 terms of a recursive sequence modeled by the equation t to the n equals 2tn minus 1 plus 3 if t1 equals 2. So what this is telling us is that the first term is 2, and then every term after that, tn equals tn minus 1 plus 3, means to find the next term, we're multiplying the previous term by 2, and then adding 3. So that's T1. T2 would equal 2 times T1 minus 3, or sorry, plus 3, which gives us 7. Continuing on, we have T3 equals 2T2 plus 3. T4 is 2 times T3 plus 3. T5 is 2 times T4 plus 3. So we're going to plug, we know T2 is 7. And we're going to work through that. We know T3 is now 17. So we're going to work through this. And we know T4 is 37. So again, we're going to work through this. And we end up with 2, 7, 17, 37, 77. Now, in terms of notation, you'll often see the following notation. So Tn is whatever term in the sequence you're looking for. Tn plus 1 is the term after Tn. Tn plus 2 is 2 terms after Tn. Tn minus 1 is the term before Tn. So you may need any of those. Sometimes these recursive sequences do have to do with what comes after. We have another example. Determine the first 7 terms of the recursive sequence formed by the equation Tn equals 2 Tn minus 1 minus Tn minus 2, where T1 is negative 1, T2 is 2. So they're telling us, again, T1 is negative 1, T2 is 2, so we know those first 2 terms. We're going to start with T3. Now the difference between this one and the last one is this one has to do, needs the previous 2 terms in order to find the next one, whereas the other one only needed the previous one. So T at 3 is 2 times Tn minus 1, which is T2, minus n minus 2, which is T1. T3 is, so we know T2 is 2, T1 is negative 1, and we are going to work through this. Subtracting a negative gives us positive, so T4 is 2 times T3 minus T2. T3 is 5, T2 is 2, gives us 8, and so on. T5 is 2 times T4, which is 8, minus T3, which is 5. Now, you will sometimes notice a pattern, as for example, this one we're adding 3. It just happens. We end up adding 3 every time. So with these recursive formulas, sometimes they can turn into an arithmetic. If that's the case, you can create an arithmetic formula and work from there. So we have negative 1, 2, 5, 8, 11. We should end up with 14 and 17, and we can test that. T4 would be 8, gives us 22 minus 8, or 14. Last one, T7, is 2 times T6, which is 14, minus T5, which is 11, gives us 28 minus 11, or 17. So we can see it actually ends up being an arithmetic, and with that we can call it negative 1 plus, we're adding 3 every time to the n minus 1. So if, once you do a couple, you can see that it is a pattern that you can come up with a general term for, that's fine. You can come up with a general term, work from there, and finish the sequence. This one, we need to determine the equation of the following recursive sequences. So to do this, I would kind of look for what kind of patterns. Again, recursive sequence means we are somehow involving the terms that come before it. So look for what patterns do we think we can try. This is sort of guess and check. Essentially, usually you're going to be multiplying the term before what the term you're looking for, or a couple terms before what we're looking for. We've had one example where we just multiply the term before and add something. We've had some other examples where it's involved two terms before. So I would always start with the one term before. So looking at that first one, our first term is 4. Again, I would always try something that only involves one of the previous terms first and go from there. So to go from 4 to 9, I'm thinking what multiple of 4 gets me close to 9? We could try 2 times 4, which is 8. And then if we add 1 to that, we get 9. So now I'm going to try another term. Or let's try the same thing on the next one. So if we try 2 times 9, that gives us 18. Adding 1 gives us 19. Try it again. 2 times 19 gives you 38. Adding 1 gives you 39. So that seems to be the pattern. What we're doing is we're to get Tn, so to get the next term, we're multiplying the previous term by 2, and then we're adding 1 to that. So there is the equation for the first one. Again, for the next one, you could try a similar thing. So maybe 3 times 2 gives us 6, minus 1 gives us 5. So it might be the pattern. Let's see if it works. 5 should be 5 times 2 gives us 10. But in that case, we have to add 1 to get to 11. So that's not the pattern. So we need to kind of look at what could we be doing instead. Maybe it's got to do with the two patterns, or with the two previous terms. So again, let's try. We're going to try 2 times 3, which gives us 6. Adding the next one, so plus 5, gives us 11. So that was T1. That was T2. Gives us T3. Might work. Let's try it again. 2 times 5 gives us 10. Plus 11 gives us 21. So that is T2. That is T3. That is T4. Seems like it works. Let's try it one more time. 2 times 11 gives us 22. Plus 21 gives us 43. So that is T3, T4, and T5. So what this seems, the pattern seems to be, is we multiply the term that's 2 before it, and add the term that's 1 before it. Oh, sorry, multiply Tn minus 2, that should say, by 2, and add the term before it to get the term we're looking for. Or in other words, we can say Tn equals 2 times n minus 2 plus t to the n minus 1. So again, we're multiplying the term 2 before it by 2, and then adding the term 1 before it. Again, these recursive sequences can be quite difficult to figure out. It is a lot of trial and error. So after looking at this one, C for a while, again, and trying certain things, so I thought maybe times 8 by 2, times 8 by 3, times 8 by 4, what's it get us? Do we have to add something? But so the difference between 8 and 39 is so big compared to the difference between 39 and 70, when we comparatively, that it's probably not something to do with just the one term, so maybe try something to do with the next term. Again, I would always kind of start small, and so what I figured out was if we multiply, so 2 times 39, that gives us 78, and I'm going to look at the other term that came before it, which was the 8, and think about, can I use that to get to 70? I can. What I can do is subtract it by that term, gives us 70. So again, that 39 was T2, that 8 was T1, 70 was T3. What I'm going to do next, try it again. So what I think might work is multiply the term before it by 2, subtract the term that's 2 before it. So we're going to try to get 101. We're going to try multiplying the term before it, which is 70, and that gives us 140, and then subtract the term that's 2 before it. 140 minus 39 gives us 101. So again, this is T3, that 39 was T2, and it gave us T4. I'm going to try putting it together now. So 2 to get 132, we're going to try multiplying the term before it, subtracting the term 2 before it. So that one was T4, that was T3. That's going to give us 202 minus 70, or 132, which is T5. So what we figured out is to get the term we're looking for, we're multiplying the term before it by 2, and we're subtracting the term that's 2 before it. Last one, again, we're going to try to figure out what can we do. I always like to start looking at what can we do with just one term, so the one previous term to give us the next one. Again, it's a lot of trial and error. In this case, if we multiply 16 by 2, gives us 32. We need to add 5 to that to give us 37. So that was T1, that 37 is the T2. Let's try that again. So 2 times T2, which is 37, plus 5 gives us 74, plus 5, or 79. So we multiplied T2 by 2, added 5, gave us T3. Try it again. 2 times 79 plus 5 gives us 158, plus 5, or 163. So it seems that this works. Again, this was T3, multiplying T3 by 2, adding 5 gave us T4. So it seems to be that the pattern is T to the N equals 2 times the term before it plus 5. So there's our pattern for that one. There's a pattern for that one. This one, again, recursive formula, it is sort of a lot of guess and check. You kind of have to try some numbers until you figure out the right formula. So, last one, another example, given that Tn equals 3 times the term before it minus 2 times the term that's 2 before it, they're giving us the first two terms. T1 is negative 2, T2 is 1. Again, we're just going to plug these into the formula we know, so that's T1, T2, we're looking for T3, is equal to 3 times the term before it minus 2 times the term that's 2 before it. So T3 equals 3 T2 minus 2 T1. We're going to plug in what these are. So we get 3 times 1 minus 2 times negative 2 gives us 3 times 1 is 3. Negative 2 times negative 2 is positive 4. Gives us 7. T4 is equal to 3 times T3 minus 2 times T2 equals 3 times 7 minus 2 times 1 gives us 14 minus 2, or 12. Oh, sorry. That's not right. 3 times 7 is 21 minus 2, so that's, 19. So we know -2, 7, 19, t5 equals 3 times t4 minus 2 times t3 equals 3 times 19 minus 2 times 7. 3 times 19 is 57. Minus 14 gives us 53. It's asking for the next 4 terms. I'm going to stop there. So we get 53. So again, recursive formula, we're using the 2 previous terms for it to get the next one. The homework for this is listed there. This 447 is mid-chapter review, which is optional, but the more questions you try, never hurts. So you can try those out. We will do, we're only going to do 2 more notes, Monday, Tuesday, so the test absolutely will be on Friday. So just make sure you're preparing for that. Again, mid-chapter review. I will post the actual test review sometime next week, early next week, so you can get ready for the test on Friday. Have a great weekend. See you guys all on Monday.